So we're going to do another volume of a solid. And we're going to use some pretty common functions, but we're going to go about y equals -3. So when I graph this, it's two even functions again, y equals 1 and y equals x to the 4th. So we have our area here. Hopefully you guys see that the intersections are 1 and -1. All right. But now I want to rotate this about y equals -3. All right. And again, first thing you got to try to do is picture rotating that little hazed region here, right, about y equals -3. Does everybody see it has to be a washer still? This still has a void. The only way that this would be, the only time this would be a distance, we took it about y equals 1. You can see that? Yeah. Yep. So here we go. Since they're even functions, I am not going to waste time. I'm going to go immediately to doing this. I'm going to go 0 to 1. I'm not going to deal with the mirrored portion. I know the volume will be the same. I am, every single time we do this, Mr. Anderson is always going to take the time to draw the picture and label it in terms of basically like algebra 1. So this is a case of pi RO squared minus pi RI squared dx. But as always, you can't leave it in terms of RO or RI. We have to get this in terms of x. Now, this gets a little more complicated because if I draw the inside radius, you guys agree now the inside radius is x to the 4th function. All right? So if we look at this, you guys see it's going to be, now it's been like the number minus the function. But what's the upper function this time? The upper function is the curve, right? So think of it this way. It's x to the 4th, right, the curve, minus a -3. Or else, here's what I want you to see. Do you guys see how this is going to be 3 right here? And how this portion up here is going to be y? So when we do these functions on the inside radius, I think this one's going to be 3 plus x to the 4th. Everybody, what's the outside radius this time? Well, 3 minus a minus, or 1 minus a -3. I think the outside radius is always 4, right? -3 to 1. It's always a constant. Now again, this time I'll take some time and we'll actually do the integral. It's 4 squared minus 3 plus x to the 4th squared dx. If I'm going to do this integral, I can't do a u substitution because I don't have an x cubed in this term. So I have to expand it. I have to do the binomial expansion. I think I get 16 minus 9 plus 6x to the 4th plus x to the 8th dx. Again, notice I'm careful to make sure that I don't screw up the distributing of the sign here. All right? And then I get 2 pi times 0 to 1. If I distribute the negative and combine 16 and 9, I get 7 minus 6x4 minus x to the 8 dx. That's good so far. Here we go. All right, everybody. Now, again, dragging the 2 pi along. One thing math teachers like to do, and again, I know I'm weird. Even though it's 7x over 1, right? Everybody, one thing I saw on your test that I can't say at this point, you got to be real careful. You should be able to track the derivative of each term and make sure that it works, all right? When you do antiderivatives, that's the easiest way. Now, it's 2 pi, and I'll use, I love seeing, this is why you like use 0 instead of -1. This is why it's worth our time. 7 minus 6 fifths minus 1/9. minus 0 minus 0 minus 0. So I know I plugged it in, but it goes away. 7 minus 6/5 minus 1/9. This is why calculators were invented. All right, so 35 minus 6 is 29/5. 29/5 minus 1/9. Oh, yuck. If it was 30, it'd be 270. It's 265 minus 5. 260 over 45, is that right?
256.
256 over 45, darn. Times 2 pi the whole way. So everybody, the answer is 256 doubled is 512 pi over 45. And everybody, we just found the exact volume of that region about y equals negative 3. All right. Now everybody, this is actually a real part. That's why I did this. This is like a conical part they use in big plasma torches. All right, can you picture what this actually looks like? If you look at it, you can kind of see the curve. If you do it around an axis like that, in the center, and I'm going to try to spin it a little bit. If I was to do a cross section, right? If you spin it, I suppose I shouldn't spin it. I'd keep it the same orientation for you guys. Cross section of this thing would look like this. All right? And one thing you do when you plasma, this forces the air to get faster because of the restriction in the middle. So if you're driving gases, by reducing the cross-sectional, this is on a plasma torch. A plasma torch is for cutting metal. All right.
Did you just get a weldy thing?
Yeah, someone has to design the weldy thing. All right. And this is one of the applications, guys. This solid actually exists. All right. This solid exists in the world. Sometimes you lose grip that we're doing things that actually have meaning, right? You feel like they're just random curves picked out of the thin blue air. Like every day. And there's reasons that it's x to the 4th. That has everything to do with fluid flow, all right? 045, thank you.